Now we have lecture of cardiovascular system development. دكتورة إيناس فاضل كاظم. First of all, we must know about the establishment of cardiogenic field. The vascular system appear in the middle of the third week. This is the time of development of cardiovascular system, and it is began with the cardiogenic progenitor cells, which is lie in the ectoderm, immediately lateral to the primitive streak, and cells resides in the splanchnic layer of the lateral plate mesoderm. They induce by the underlying pharyngeal endoderm to form a cardiac myoplast. As we see in this picture, we have A, B, C. A showing the blood vessels and blood island, while B showing the pericardial column and cavity. And C, there will be a cardiogenic mesoderm and septum transversa. Later we will discuss it. Blood island appear in the mesoderm, where they will form blood vessels and blood cells in a process known as vasculogenesis. So, what do we mean by vasculogenesis? Vasculogenesis is the process of formation of blood vessels and blood cells by unations of blood island that appear in mesoderm. So, with time, these islands united and form a horseshoe-shaped endothelial-lined tube surrounded by myoplast. This region now is called cardiogenic field. Now, what is the cardiogenic field? Is a horseshoe-shaped endothelial-lined tube surrounded by myoplast, and it is originated from the unation of the blood island. The intra-embryonic cavity over it developed into pericardial cavity. In addition, the blood island appear bilaterally and parallel close to the midline of the embryonic shield, and then they will form a pair of longitudinal vessels known as dorsal aorta. So what is the cardiogenic cavity? Cardiogenic cavity is pericardial cavity that is laid over the cardiogenic fields. And what is the origin of the dorsal aorta? The origin of the dorsal aorta from the unations of the blood island form a pair of longitudinal vessels, which is called the dorsal aorta. In this picture, we see the blood island in A and the formation of the blood vessels in process of vasculogenesis, and in B we see the pericardial cavity, the white area, and under it the blood vessels, and in C we see the cardiogenic mesoderm and the septum transversum. As I said before, I will discuss it. Now we became to the formation and the position of the heart tube. As I said before, the horseshoe-shaped area that is formed before, now it will be expanded, and the result of this expansion is forming of the future of outflow tract and the ventricular region. Now, because of this expansion, the ventricular region of the heart will appear. Thus, the heart at this time becomes expanded. A continuous expanded tube consists of a two-layer, which is inner endothelial lining and the outer myocardial layer. And there will be a pumping at this time also of the blood with the two poles, caudal and cranial pole. It receives the venous drainage from the caudal pole and begins to pump blood out of the first aortic into dorsal aorta and its cranial pole. So as a result, at this time of the after formation of the heart tube, this heart tube will be expanded and forming the ventricular lesion, and there will be now the heart consists of the two layers, which is endothelial and myocardium, and it will be receive the venous drainage from the caudal pole and began to pump the blood out of the first aortic into the dorsal aorta and then into at the cranial pole. And we said before, the dorsal aorta is originated from the unation of the blood island. As we see in this picture, head of the embryo, as you see, and the blood vessels, or blood, say before, this is the blood island, and then we have the tube, heart tube, which is expanded to form the ventricular region, and after that it will be of two layers, endothelial layer and myocardium, and also myocardial layer, and then there will be a pumping from the cranial, the pumping of the blood out of venous drainage from the caudal area and the cranial area, example the aortic aorta. So the developing of the heart tube bulges more and more into pericardial cavity. The heart tube began expanded, and it will be remain and attached to the dorsal side of pericardial bifold of mesodermal tissue, just called the dorsal mesocardium. So what is the dorsal mesocardium? Dorsal mesocardium is a fold of mesodermal tissue that will be connected of the heart tube to the pericardial cavity. After what? After the heart tube bulge more and more and expanded. Once the dorsal mesocardium disappear, will be a creating of a new structure called transverse pericardial sinus, as I said before, and we see in the last pictures, there is a transverse pericardium area. This transverse pericardium area resembles the transverse pericardial sinus. This area is creating after the disappearance of the dorsal mesocardium. This sinus connects both sides of pericardial cavity. So as a result, now the heart will be now suspended to the cavity by blood vessels and its cranial and caudal pole. There is no connection of mesocardium. There is no connection of mesodermal tissue, but now there will be a development of blood vessels with cranial and caudal poles and hanging the heart into the pericardial cavity. During this event, so now we have a myocardial thickens and secrete a thick layer of extracellular matrix, which is rich in hyaluronic acid. Why it will be secreted of hyaluronic acid? So this acid will be separated the myocardium from the endothelium layer. In addition, there will be a mesodermal cells from the region of the sinus venous migrate over the heart to form the epicardium. As we see in this structure, the dorsal mesocardium, which hanging the heart tube into the cavity, cardiogenic cavity and pericardial cavity. Once I said when it's disappear, so it will be turned to sinus, and now the heart will be connected with the blood vessels, and now we have development of the layers of the heart, which is epicardium, endocardium, and myocardium. At the end of these events, at the end of development and establishment of the heart tube, now the heart consists of 3 layers, which is first endocardium, forming the internal endothelial lining of the heart. Second, the myocardium, forming the muscular wall, and the epicardium or visceral pericardium, covering the outside of this tube. This outer layer is responsible for the formation of the coronary arteries, including their endothelial lining and the smooth muscle. Thank you for your listening.